Okay, so here we are again. Before I get started, are there any questions about what we've been doing so far? Okay, I'm going to start today with trying to finish up the example from yesterday. And as simple as this is, it does illustrate, I think, some kind of what subclassing is about, and will hopefully clear up some things about that. So let me get this thing going. Where are you? Yeah, one thing that Zoom doesn't, if you have something open but minimized, then Zoom won't show it in the share thing. So, okay, so yesterday we, just to review, this, actually, you know, tell you what, let me share the whole thing. Just okay, so the idea is that we have a superclass. In this case, the superclass is called pet. I mean, there's it's just a class. When it was written, it's just a class, but we designated a superclass because it has two subclasses. In other words, pet is a superclass of cat and a superclass of dog. And cat is a subclass of pet, and dog is a subclass of pet as well. And what's not shown here is that pet itself is a subclass of the class called object. So every class that you write is a subclass of some other class. What I hope to, some of the things I hope to get across on this are what happens when we subclass, and in particular, we went through what's going on with the constructors. This also illustrated overloading of constructors because, as you can see, there are two constructors for cat with different signatures and two constructors for dog with different signatures. So we implemented cat. So here's pet. And again, everything in here comes directly from this UML diagram. So pet listed, well, starting with the name, pet corresponds to a class called pet. The two instance variables, name and breed of type string, directly correspond to two instance variables called name and breed of type string. And the thing that's not shown in the UML is that they are declared private. So all instance variables must be declared to be private. In this class, there will be no exceptions to that. It's unfortunately a little bit easy all too easy to leave the private out, especially if you're coming from a non-typed language like JavaScript or Python, where you just kind of leave it out. I mean, there's no notion in those languages of private or public or anything else. So when you're switching between the two languages, when you're in Java mode and you're looking at an instance variable, it must be private. That's just something to keep in mind. Again, constructor, in this, the constructor was specified. Typically, if no constructor is specified, then you have one with a 0 argument. And as we've mentioned, Even if you don't write a constructor, Java will put one in for you.
I had a question.
Yes.
So for when we make all the instance variables private, and that's the reason we have to have getter methods. Otherwise, if it was public, then we wouldn't need the getter methods.
That's true. If it were public, you wouldn't need the getter methods. However, if it were made public, that would violate encapsulation, which is one of the bedrock principles of object-oriented programming. In other words, every object must protect its state, that is, its instance variables, and not allow any other object to modify them directly. If you want to modify if you want to change what's going on, or even change the value, then you write what's called a setter. And that allows other objects to make changes to it. But, you know, I'm a little concerned by the phrase "you don't need to," because in object-oriented programming, you need to keep them private.
Or do we still need to use setter methods if it's something within the same class is trying to change its instance variables?
Within the same class, they're not strictly needed. Depending on the context, in these simple examples, there really hasn't been a need for it. In more complicated examples that we'll encounter, there will be a setter method, and there you have the option. In other words, okay, this may sound like a tangent, but remember I talked about scope. So a class, the scope is defined by the curly braces. The curly brace on a class it's right after the name of the class, and it ends at the end of the class. So the scope of instance variables is the entire class. What that means is that every method inside that class, every instance method, including the constructor, can have access to this. So within the class, you have full access to all of your instance variables. Okay, and there are good reasons to only use the setter methods within the class, even if you're changing the value within the class, and we'll see some examples of that. That is not as strict a rule in object-oriented programming as this idea of making everything private. Well, when we encounter that, I'll go into that a little bit more detail. So as you notice here that, okay, within the constructor, we can set the value. The getter methods, they have access, they can return the value, and then in the toString also you have access to the value. So if you have access to a variable, you can do whatever you want to it. You can change it. If it's an array, you can change the value of a particular index. Okay, so what we did with the cat subclass, again, what it did was it added an instance variable called long hair, which is a Boolean, which is going to be either true or false, and had two constructors. It added another instance method called meow, which presumably not all pets will do, and then a getter for the instance variable long hair. So what we learned in the process is that oftentimes for a Boolean instance variable, the getter is called is instead of get, just that. And then here, the toString was overridden. And the way that was implemented was to, again, here's the instance variable, private. Here's one constructor, and it calls super. Here's the other constructor, and it calls this. So this is, whether you use super or this is, in this particular setting, it doesn't really matter so much. But one of the things that you're after in programming is a single point of failure. And you're all familiar with the concept of a single point of failure. So the reason why it's ideal to have only one constructor called super, and if there are other constructors, to have them called this, is this single point of failure. In other words, when I instantiate a cat, regardless of where it's from, I always have to go through this constructor. If I went to super here, then now I have 2 points of failure. I have 2 ways that I can, if I construct a cat, there are now 2 ways to get to the superclass. So it's not that this is wrong to call super, it's just that this is slightly preferred, or not more, it is preferred because of the principle of a single point of failure. Okay, the other thing that we encountered in the process of this is that I can invoke, if I'm especially if I'm overriding a method. Okay, so the toString is overriding, meaning that it's replacing the, in this case, the one in pet, the one in the immediate superclass, with another one. In this case, sometimes you want what's in the superclass. In other words, and this is true of any method. So in this case, I already have the name and the breed listed here, so I don't want to have to type that again. That's one of the programmer virtues of laziness. So laziness as a virtue says that if I have already implemented something, like here in the toString, I don't want to type it again. The principle is that if, the optimal number of times to implement any particular piece of logic is 1. So what I want is I want the name and the breed, but then I also want to know, is this a long hair or not? Okay. So I call super dot toString. So super, just as a general thing, refers to the object that is in the immediate superclass. Now, the interesting thing here is this. As a pet, as a subclass of pet, every instance of cat has a name and a breed. Otherwise, this wouldn't happen. So, however, because these are declared to be private, so particularly, say name is declared to be private. So the cat object has an instance variable called name, but it's part of the superclass. And because it's private, cat has no reference to that. So for example, okay, you would think you would be able to do this, but notice that I can't. It says name has private access in pet, and I get a red squiggly. I'm not allowed to directly access this. So that this private thing, it locks it up tight, and that's what you want. I want it to be locked up tight. In other words, I don't want anyone, even a subclass, to be able to mess with it. Okay, so so we tested. We had instantiated a generic pet, and then we'd instantiated a cat, and then we'd run that, and then okay. So you see that when it's just a pet, we had this, and then when it was a cat, it added this. Yeah, and actually when we said meow, the meow was saying, okay, let's just sort of print this. And again, this is this is something that in general, this is just for a class example. In general, you should not have print lines in objects like this, just as a general thing.
Would you use that for testing though, correct?
Yeah, even for testing, this is this is an artificial class example. So even for testing purposes, you do not use print line in testing for testing. This is just because I need to implement something here, and there really isn't anything that I can do other than just kind of print something.
If you need like statements or console logs, what would you put instead of that then? For a test, for like doing debugging and stuff.
Well, if you're debugging something, then that's where you use like getter methods and things like that. In the, you know, notice in your main classes, it's okay, that's where you can put print lines. See, here's the problem. The problem is that just as with surgery, there's no such thing as a trivial edit of a class, of any code. Anytime you edit something, there's a risk of screwing it up. So let's say you have print statements in your component classes, like in this case, pet and cat are examples of that. Oops. So let's say I get it, you know, if I'm relying on those print statements, let's say I get my class to the point where I believe that it's correct. But then in production, those print statements are just going to be spamming the console. So in a long production run, as it were, I mean, we've just seen small, simple cases here, but in a longer program, if I have print line statements in there and I've left them there, then they're just going to spam, you know, the output, and I don't want that. So what do I need to do? Well, one of the things I need to do is I can go in and I can either delete them or comment them out. But what have I done? I've taken a class that was perfect, and then I've edited it. And if you takes a class, anything that's perfect, and change it, can you be 100% sure that it's still correct? That's a rhetorical question. The answer is no. So that's why print statements inside a class like this are not a good idea. Now, I mean, if you want to see what's going on inside them, then really a better solution is to use the debugger. And we will, at some point, we'll talk about how the debugger works. And that's a much better way, a more effective way of debugging. I mean, that's of debugging your code, because the debugger is literally built for that. Okay, now I see one thing that I kind of fat-fingered yesterday, in a way, not so much fat-fingered, I put in the wrong place. Notice that I put this test pet class in the cards run package. And that was by mistake. It was sometimes I'll do things deliberately wrong just to illustrate that. This unfortunately wasn't a case like that. So I put test pet in the wrong package. NetBeans, one of the nice things about NetBeans, and it's this refactor thing. If I really want my test pet to be in this package. Okay, and here again, just to confirm, see what package it's in, the cards package. The pets have nothing to do with cards. I don't want it there. I want it in this package. So all I got to do is just grab it over here in the projects tab, in the projects panel, drag it and drop it onto the one I want, And this just sort of says, okay, do I want to refactor? This refactor thing is a very powerful tool. We've seen examples of it. But if I just say refactor now, test pet is over here. And it says renamed and et cetera, et cetera. And notice that it's in green because now it's been added. Okay, so now let's I want to do the dog just to complete this, and then show you what the implications are for the type. Okay, so let's do our dog. Okay, now how do you subclass? You say extends. Okay, and then again, then don't panic when you get the immediate red squiggly here. Whenever you get the red squiggly, don't just sort of flail around trying to make it go away. Understand why it's complaining, and direct your efforts towards fixing that. Okay, constructor cannot be applied to given types required string found no arguments. Again, it's really important to understand what you need to grab onto to understand what's going on here. That Java has added a constructor to dog, and it's added a constructor with 0 arguments, and that's not so much the issue. But then after it added the constructor, it said, oh, I see this constructor does not immediately have a call to super or this, so I'll put in a call to super with no arguments. That's the cause of this error, because now there's a call to super to the pet class, but the pet constructor requires 2 strings. Okay, now I'm going to show you actually a slightly different, a slightly better way than I did yesterday. Is that I'm going to start with the big constructor, with the larger one. Okay, and notice it's still complaining. All right, and again, why is it complaining? See, because I have a name and breed and everything like that. I still have not written super or this. And so Java's putting it in for me. It's putting in a super with no arguments. That super is calling pet with 2 strings, and the compiler saying, nuh-uh. Okay, so when you have a class that has a constructor that requires arguments, a good practice is to have a constructor in the subclass that at least has those same ones, and I like to name them the same way, just to, that's not required. These names of things, I can call it whatever I want. But just to avoid confusion, this is much clearer. Okay. Now, now I'm declaring my instance variable so that I'm setting it there. And when I create the getters, and again, this encapsulate fields business allows me to just create my getters with a couple clicks. So I don't have to do any typing to create a getter. So the idea of kind of having only allowing, and if I had to generate a setter, that would also require just the same number of clicks. Okay. So, okay, looking at dog. So I have one constructor. I have my instance variable. I have my Boolean. And now I still need to write the other constructor. I need to write the bark and the toString. So now what order you do in doesn't really matter. I'll do the toString first. And again, just as with the cat, I'm going to use the super toString of pet and then just append the additional one that I have. And that's, you know, if for some reason you, well, supposing I, whatever reason, wanted to be, to do extra work. Supposing I wanted to have all that. I could not write the same thing. See, I can't do that because it has private access, but I can do this. See, so if I wanted to do it this way, I could do it that way. That works fine. Okay. But laziness, so notice the difference here. So laziness says that what I've done here is not only less typing, but more to the point, it has a single point of failure for this piece of the string. In other words, the single point of failure is right here. In other words, I've written this piece of the string once, and as long as I'm content with this being correct, then I might as well use it. Okay, so now just you know, again, this is a state of sin, but okay, this is just to kind of do something in a how should I say, in a more complicated context. This wouldn't be necessary. In other words, if I had a method that was doing something, it would be doing it. For this simple class example, there's nothing, I don't have anything I can do there. Okay, so here's the thing is that I still have, looking at my design, how much have I implemented? I have this constructor, I have the instance variable, I have bark, I have isLarge, and I have the toString. But what about this shorter constructor? And this is actually kind of the in a way kind of a better pattern for this. So if I just have if I instantiate a dog with just a name and a breed, then it's going to have to be large. I mean, in other words, large is going to have to be something. The default value of an instance variable is, depends on the default value of that type. The default value of a Boolean variable in this context is false. Here's the thing though, you should never rely on the default values. It's useful, it's important to know what the default values are. And it's equally important, if not more important, to not rely on them. So I want a default value. So if I just say I want a dog, and I'm not going to, I'm going to take the default value of whether it's large or not. Now that's kind of it's kind of an arbitrary thing, but just for the sake of this example, I want the default value to be something else. I want it to be, let's say I want the default value to be large. So if I'm creating a small dog, I need to explicitly tell you. And if I'm just say, here's the name and the breed, and use that other constructor. And again, this is going to red squiggly me here. I need to say either super or this. Now I could say super, and that would make the red squiggly go away. But that isn't the best design. What I want in this particular case is to have a default value. And this is where those class variables can come in. So I'm going to define a class variable, which is going to be the default value for large. And the thing is now class variables, they can be made public if they're made final. And here's how I define it. Okay, so let's unpack what I've just done here. Okay, first public, I've made it public. Now, this is not an instance variable, it is a class variable. And you identify a class variable by the keyword static. See, there's a, okay. Okay, the keyword static, remember here, what's the difference? An instance variable, there's one per object. A class variable, that is a static variable, there's one per class. So there's only going to be one of these. Okay, final, we haven't, we may have encountered that, but final means this cannot be changed. And that's why it's safe to make it public, because nobody can change this value. It's a Boolean. And then notice that I did the convention, and it's only a convention, but it's one that should be followed for static final variables is to be all capitals separated by underscores. Okay, so what this says is that if I don't tell you whether a dog is large or not, I will use this value. And so, see, instead of having two calls to super, I have one call to this, but this shouldn't let me do this, but okay. Now, the thing is that, again, think scope. As far as scope goes, all instance variables, all instance methods can have access to both the instance variables and the class variables.
When you put this with the parentheses there, what does that actually, what does that mean? Like, is that dot name equals name?
No. What this does in the context of a constructor, the first call, the very first call in a constructor must be either super or this. If it's, and I'll get to your to answer, but just I want to put it in context. Again, a call to super, this calls the superclass constructor. A call to this calls the constructor in the same class. So this, with a parentheses, calls the dog constructor with string, string, and Boolean. And this ensures that the large instance variable will always be set explicitly. In other words, every time I construct a dog, it has to go through this constructor. Single point of failure. And what that also does is that ensures that I have explicitly set the value of large. I haven't relied on the default value. The default value of a Boolean is false, but the default value I want here is true. So to make sure that that happens, if I just give you a name and a breed, it will give me true. All right, let's.
Is that for clarity's sake that you do it that way, or could you just write in that constructor? Could you just write name breed true?
Yes, I could do that.
Okay.
Yeah, good point. Okay, why do it this way? Because of something you're going to hear me sort of talk about a lot, which is programmer intent. You want to, when you're writing code, you want to write it in such a way that if somebody else were reading it, they would be absolutely clear about what you were trying to do. You want to do that whether your code is correct or not, especially if your code has a problem in it. You want to make it absolutely clear what you intend to do, so that you can debug it. And when I say somebody, most of the time that somebody is you. So I mean I can barely remember what happened to me yesterday. When it comes to code I wrote 2 weeks ago, all bets are off. So if I'm reading code that I wrote 2 weeks ago, I mean, as soon as I put aside my first reaction, which is who wrote this crap, if I'm trying to figure out what the heck was I trying to do, I want to make that absolutely clear. So if you're absolutely correct, I can put true in here. And the only problem with that is that kind of hides a little bit. I need to see this in order to see what my intent is. Whereas this, when I put the default large like this, see, this is part of the, when we talk about something called Java doc, this will be kind of out there. This will be part of it. So in other words, this just kind of makes it absolutely clear what I'm trying to do. When I say, and especially if I name it default large, that indicates that my intent is the default value of large is supposed to be this value. Okay, so let's test that out. So let's create a dog. Okay, and again, this can sometimes seem a little confusing. You say, why am I getting a red squiggly here? And again, always, when you're trying to, obviously you want to make all the errors go away, all the red squigglies disappear, but you want to direct your efforts towards what Java's complaining about. Okay, whenever you say cannot find symbol, the very first thing you should do is right click and say fix imports. 9 times out of 10, that'll fix it. Here's an example where it won't fix it. So either I haven't imported or I fat fingered it. Okay, so here I've fat fingered it. So like I said, first thing you do is fix imports, and it does nothing. So if it does nothing, that's an indication I probably fat fingered it. So yes, I fat fingered it, and there it is. Okay, so now let's Okay, so now here's where you were kind of asking me about the single point of failure and kind of why kind of do this instead of the other. Look at this toString that I have, and especially when we're kind of putting stuff out. Notice that I don't. I have name, and then the name, and then between that I just had a space. I didn't put any other kind of delimiter. So just for ease of reading, it would be nice to have a delimiter there. So what I can do now, at least for the pet piece, all I need to do is put the delimiter, come on, say put the delimiter in the pet here. So I'll just put an upper score here. And now it see, it feeds forward to all of them there. Now, for the subclasses, I would also need to do something, but you see that whatever I did here in this one place now feeds forward to everything else. Good question. Okay, so this is this is where I said Billy was a short hair, but long hair came out to be true. So what that suggests is that I should do this. Better? Thank you. I mean, okay, so now
Where was the print statement from the dog coming from?
for the bark. And again, this is don't again for anything I ask you to do, don't put print statements in. I mean, if you can now, I can't stand over you when you're writing stuff, so I can't prevent you from putting them in while you're developing. But if I see them on what you're submitting, I'm gonna, at the very least, complain. Okay, so now I want to make a point here, and I can see that I haven't gotten to anything I wanted to talk about in the class. I'm still on yesterday's class, but this is important, and I hope that this is clarifying some things for you. That's why I think it's worth it to spend the time to kind of go through this. Now remember that class is also a type. And we see that over here. So here I've defined a variable called pet, a variable of type pet. Here I've defined a variable of type cat, and here a variable of type dog. So now here's the thing, is that I can assign I can assign okay, notice no red squiggly. I can assign a dog to a variable of type pet. Why? Because a dog is a pet. A dog is a pet. I cannot assign okay, red squiggly here. Incompatible types. A pet cannot be converted to cat. So a cat is a pet, but a pet is not a cat. Okay, so this can't be done. Now, one of the things I can do though is, and this is where it comes in. Supposing I had you know, a menagerie of cats and dogs. Yeah, you're probably right. Okay, so maybe I should call him, you know, sorry, my knowledge of cats and dogs is greatly exceeded by my knowledge of Java, so by a lot. So that is okay. So one of the things I can do let me is, okay, what have I done here? I've defined an array of type pet. And the thing is that I can notice that I can assign both cats and dogs to this array of pets. So this is part of, if you're thinking, okay, why even do this in the first place? Because both a cat and a dog and any other subclass that I might define is a pet if I'm creating a bunch of them and I want to kind of keep them all together. So let's say I only have cats and dogs, and in my program I want to kind of keep them all in one place. Well, one place I can keep them in is an array of pets. And if I want to just print them out, okay, I'll use the for each construct. Okay. So notice no, you know, Java's not complaining because it lets me put all of these into the same array. You see that? So now I can have this sort of mixed bag of pets. As long as I call them just pets, then I'm good. Now, what I can't do is, let's say, okay, I know that my pets is a cat. Oops. All right. So I know that my pet's one is a cat. And so it should be able to meow. But the problem is that even though the object itself is a cat, I've only declared it to be a pet. And so a pet does not have the meow in it. See, oh, that's only the cat that has the meow. See, so this is illegal, even though this would work as I've done it here, but Java doesn't know that. So this should give you an idea of what the compiler does. Again, when you get red squigglies, that's not the virtual machine, which is what when you run it. This is the compiler. The compiler is saying, I cannot guarantee that when you invoke this method, it's going to work. I can't guarantee it. And if I can't guarantee it, I'm not going to let you run it.
Can you change the element, or is that forever? All elements will be in the pet structure or pet type.
Well, I mean, if my pets is and forever will be an array of pets. Once I've defined a variable to be a particular type, it's that forever, at least as long as the program's running.
So can you have an array of different elements, or is that you would have to create a class to create that type that would have the different elements?
Now, by different elements, what do you mean? You mean things that are totally unrelated?
Could you have like integers and strings and like a pet type inside of an array, and where it wasn't assigned to a specific element, like the 0 spot, the 1 spot, the 2 spot?
Great question. And the answer is yes. However, what you need to do is you need to go all the way up to the granddaddy of the classes and define it to be an array of objects. Okay, so object, remember, object, and this is unfortunate terminology, but we're stuck with it. Object with a capital O is not an object, little o, it's a class, the name of a class. So my stuff is defined to be an array of objects, and I can put any object in there. So my stuff 0, I can put a string.
But if you put like you put all your pets in that array, like will they be able to access stuff like .meow?
Nope. Well, yeah, yes and no. I'll get to that in a second. Now, it's gonna let me put. Is that an int? My stuff 2 is. Let's put a cat in, and then what do we got here?
So we're 2 minutes over on time, just so that you know.
We are, okay. Just to answer the question here. See that my stuff here is coming there. So the answer to the question, can I put all this stuff into an array? Yes. I have to do it this way. Okay, so apologies for going over.